Hi, welcome to the unboxing of the Biology 210 Lab Kit. So you should have just picked up a box that looks like this from the East Peoria campus. And what we're going to do is we're going to go through what each of the items are, their purpose, how to store them, how to use them, etc. So starting in week 5 of the semester, we are going to use the lab kit to do a variety of experiments. So let's start with at the bottom of the box. At the bottom of the box, you have part of what you call PPE. PPE stands for Personal Protective Equipment. So you have these 8 mats, we call these lab mats, and you're going to put these, okay, here's what they look like, on the surface of whatever you're working with, whether that's your kitchen counter or whatever surface you're going to work at, to protect the counter and also to keep any spills, etc., absorbed onto that lab mat. So let's look at what's actually going to be, besides the lab mat, part of the PPE. You're also going to have in your box, and it's bigger, I'm just not going to unfold it, a lab apron. And this is kind of a one-size-fits-all. It's going to go over your head and then tie behind your back. And you're going to want to wear that as part of your personal protective equipment to protect your clothes. You're not going to have any stains in the kit. If you come to the face-to-face lab, you'll have stains, but that will again help protect your clothes if you spill anything on yourself. So instead of a lab coat, we're using lab aprons just because they're a little bit easier to adjust as far as size. So what else do you have as part of your personal protective equipment? So you're going to have a bag, like a gallon-sized Ziploc bag, and in there you're going to have gloves. So for all of your experiments, you're going to have to wear gloves just to protect you. And we went with the size large just because we wanted to make sure it fit the majority of people. So it may be a little big on you, but it's, again, better than not wearing gloves. So you're going to have 10 pairs of gloves. So here's some both sets of gloves. And I would only unbundle their rubber banded one set at a time. And then when you get to the other set, you would use the other set. Our other part of PPE is you're going to have a package of safety glasses or safety goggles. And you're going to want to use this for every experiment that you do to, again, protect yourself. So let's look at one more item in that gallon bag, and that is going to be what's called a wash bottle. And this is actually going to serve as your disinfectant bottle. So it has markings from 25 all the way up to 250 milliliters. And what you're going to want to do at the beginning of the semester when we use these is you're going to fill this with 180, so just kind of guesstimate. There's a 150 mark, and then halfway between 250 and 150 is another mark. So just kind of guesstimate. You're going to put in 180 milliliters of bleach, like household bleach. So you're going to have to purchase the bleach. That is not included in the lab kit. And then you're going to add 20 milliliters of water. So again, just kind of guesstimate. So when you're all done, we've got our 25 mils marked down here, and we've got our 250. So when you're all done, 180 plus 20 is going to give us 200. So you can use these marks on the side. So this is our disinfectant bottle. So what is that? So in exercise 2, at the beginning of the semester, you watched a video on how to disinfect your tabletop or your work surface. That is the purpose of this bottle. So you're going to spray this on, just like it showed in that video, on your work surface. Let it sit as it was described in the video. If you've forgotten how that works, go back to exercise 2 and it will go through how to do that. It's a short, like less than 2-minute video. Let it sit for as long as it says. Wipe up the excess, and then you're going to put your lab mat down so your area is nice and aseptic or nice and sterile. And you're not going to need to fill this every single time you do an experiment. In other words, I would fill it once, and then when you run out, start to fill it again. It is very, very important for your lab kit that you keep it away from pets or children, especially for things like that might have bleach that they could get their hands on. So you're going to want to store your lab kit or the items that you're most concerned about in a secure location. So those are how we're going to begin our experiments. So we're going to have all of our PPE, our lab mat, our gloves, our apron, our safety glasses. We're going to wipe down the table. We're going to spray down the table with our bleach solution. And then we're going to get started on our experiment. So every experiment's going to work a little differently. The first set of experiments you're going to do or set up is to actually get what we call a stock culture ready. So what that means is you're going to take the bacteria that's provided and grow more bacteria. So what else is in your kit? So we're going to look at how to do that stock in just a minute. So you also have a test tube rack. So that's going to be used to hold your test tubes. And you have a little pencil box, and they're going to be a variety of colors, pencil box. And let's see what's inside the pencil box. So inside the pencil box, you're going to have 2 bacteria, each of which is in this nice bubble wrap pouch. You're going to have aseptically or sterilized wrapped. These are called spreaders. We will use these in a few weeks, so don't open anything just yet. You're going to have 7 labels to use to add to your different cultures, a Sharpie marker to use to write on things. Later in the semester, you'll use these forceps. We won't be using these for a while. You'll have a package that says antibiotic discs, and that's exactly what they are. They're 2 antibiotic discs. That's used at the end of the semester. You have another package that says filter discs. They are used at the end of the semester. You have a metric ruler, so we'll be using that several times during the semester. You have 1 box of matches, so if you run out of matches, then you'll have to use something that you have at your house, whether that's your own matches or a lighter or an aim and flame, but we provided 1 box of matches. And then we provided 1 package of sterile swabs. And again, don't open these yet because they are currently sterile, and as soon as you open them, they're not. So we're not going to use those again to the end of the semester. So these, just leave them alone. So I've emptied out the box, and that's significant because the box is going to serve 2 purposes. At the beginning of the semester, it's going to serve a purpose to hold your materials. Then in a few weeks, when we start to discard things, this is going to become our disinfectant box. So again, go back to exercise 2 and watch the video on how to disinfect. So let's say we are all done with a tube of bacteria. So I've got a tube sitting here. So let's say we're all done with this tube. I'm going to fill, not to the top, but just enough to submerge. I'm going to fill this with bleach, just straight bleach. So pour it in. I would take the lid off of my bacteria. So this is a test tube. I take the lid off. And again, enough bleach so when I submerge that in the box, take the lid off, the bleach is getting inside the test tube. And the purpose is we're killing the microbes so that it's safe for you to then discard it. So how much bleach? Enough to get the test tube submerged. The same with when you're going to have plates. And I'll talk a lot about plates a little bit later. So you're going to have a stack of 10 nutrient agar plates, which I'll get into at the very end of this, but I'm going to get 1 out just to show you. Again, when it says to discard plates, which is in a few weeks, you would take the lid off the plate, which I'm not going to do because I want to keep it. Take the lid off the plate, submerge it in the box overnight, close the box, put the lid on the box nice and tight, leave it overnight. After the 24 hours has come and gone, then you can throw the plate and the test tube, if we had a test tube, both in the trash and pour the bleach solution down the drain of your sink with lots and lots of water. Again, while these are sitting, you want to keep this away from pets and children so that everybody stays nice and safe. So the box will be used for both storage at the beginning of the semester, and then as we start to disinfect, we would take things out. If you're not using the box, meaning it's not being used for bleach container, you can rinse it out and put your items back in. So let's continue to go through some more things that you have, and then we'll kind of go back to that plate idea. So you are not going to have a Bunsen burner because it's kind of hard to do at home because you don't have gas. So instead what you have in a little box, and they're kind of cute, is a little alcohol lamp. So what is in here is 95% ethanol or alcohol. You have a little wick, okay, little wick. And if we light it, it has a little lid, that's going to serve, and I'm going to light it off camera, as your Bunsen burner. And what you're going to notice is it actually gets a pretty good flame. So again, when you're doing your experiments, you may want to do these if you've got small children at home when they're sleeping or not in the room, because we don't want anybody catching on fire Anytime you're not using it, you're going to want to keep it obviously unlit and put up because it doesn't have alcohol in it. In your Ziploc bags, you are going to have an inoculating loop. So in some of the other videos that you've seen me demonstrate, we have this in the real lab setting. And these are nice braided inoculating loops. These are the exact same ones we use in the lab. And if we're going to flame it instead of our Bunsen burner with our alcohol lamp, we're still going to hold it at an angle, and we're going to let it get nice and red hot. And it's going to take a little bit longer because you don't have a Bunsen burner. You don't have that nice hot cone of the blue cone. But you're going to, again, get the whole braided portion nice and red hot. So it's going to take just a little bit longer. So as soon as it's kind of that orangey color, it's good and sterile. And then you would let it cool. And again, you're not going to put this down on the table because you would have to start over. So when you're not using your alcohol flame, you're going to want to make sure it's unlit. And it does have a lid, okay, to keep it. And I would actually keep it in the box. And it is liquid, so you're going to have a little box here, okay, a little box that goes in there. But I would keep it in the box just so it doesn't tump over. So I flamed my loop, and now I'm going to let it cool before I do whatever experiment I'm going to do. So my loop is ready to go for my experiment. So the loop, when you're not using it, I would put it back in your Ziploc baggie. Or another option is, this is what we do in the normal lab, is you could kind of just put it at an angle, maybe, yeah, within your test tube rack so you don't lose it. That's another option. Just make sure if you flamed it, it doesn't touch anything else until you're completely done with your experiment. All right, so let's go through a few more items, and then I'm going to go through how to kind of store these and what to do when you're not using things. So what else is in your big box? So in your kit, you're going to have a white box. And it might have a word like nutrient broth or nutrient agar, and most of them I've actually blacked out, but this one apparently I did not. Just ignore what's on this front of the box because that's not necessarily what's in the box. We have a variety of things. So what you should have is you should have 4 nutrient agar slants. And they're a slant because they're literally just that, they're at a slant. This is the same nutrient agar that's in the nutrient agar plates. The only difference is it's in a test tube. So we use these to grow bacteria. We use them to basically provide bacteria with food. So you have 4 of those, which I'll get back to in a minute. You have 1 of what's called Simmons citrate, which is a nice, pretty green color. And again, it's a slant. It's an agar slant. That will be used later in the semester. You have 4 nutrient broths. So they're a liquid. Okay. And then you should have 1 of what's called phenol red broth base, and it has what's called a Durham tube in it. And basically what this is it's sugar, it's glucose. And again, you'll use this kind of in the middle of the semester, and that Durham tube is this little upside down test tube. And it's important that you don't turn this upside down because right now this is a nice pretty red color, and the Durham tube is full of media, and we want to keep it full of media because in our experiment, I actually have one, we're going to see if we can get this gas bubbles. This is the exact same test tube, but the difference is we've inoculated or added bacteria, it's changed colors, and now we have a nice pretty bubble, and that's going to tell us something, which will make sense later in the semester. So in other words, this is just a nice red tube, and this inside Durham tube, that little baby test tube is the Durham tube, should be full of media, no bubble in that tube. So if it does, let your instructor know, and they can kind of give you guidance on what to do next. So I would leave this whole box, okay, this white box, in your kit until it's ready to be used. So let's go through, that was all of the items, kind of what you're going to do the first week. So the first thing you're going to do with your kit is you're going to take a bacteria, and you're going to use Serratia first. So you have 2 bacteria that are in these bubble wrap pouches, and that's to keep them from breaking. So you're going to have E. coli in one and Serratia in the other. So you're going to have 2 bacteria. One is called Serratia marcescens, which you probably can't see. There's a little bit of a glare. And the other is E. coli. There's another one. And both of them are growing on the agar slant. So E. coli is going to kind of have a white appearance, and the longer Serratia sits out, it's going to have more of a pink or reddish appearance, but it starts off also kind of a white appearance. So you have two bacteria, and for the beginning of the semester, you're just going to use Serratia. That's the very first thing you're going to do. So here's my suggestion. To keep our bacteria nice and safe and not get contaminated, I would take your E. coli, which is in your bubble wrap pouch, and if you want to seal it up, there's actually a sticky thing you can seal it if you would like to do that. And I would do one of two things. We're not going to use this for about a month. This is the E. coli. So for about a month, we're not going to use the E. coli. So my suggestion is to do one of two things. Either to put this in the refrigerator, and if you don't feel comfortable doing that, I completely understand. Buy or find at your house, you've got lots of options, like a small cooler. So this is actually just a lunchbox. It's really cheap, really inexpensive, like a styrofoam one, like or a lunchbox, something, and just put, you don't have ice packs, just grab a baggie and stick some ice in it, and then put the bacteria in your little cooler. That also will, if you're concerned about children or pets getting it, you can maybe put that away. It doesn't have to be anything fancy. Anything that basically you can keep this cold. If you say that's not possible, I don't have the money to buy a cooler or a lunchbox, and I don't feel comfortable putting it in my fridge, you can put it back in your lab kit box, in the big box. That's fine. So it's back in the big box. Or you can put it back in your little pencil box. Obviously, you would have to take it out if it's time to disinfect. So if you want to put it in there, initially you could probably put it in there and put a little bit of ice in there. You don't want it frozen, but just cold, but it would be okay. So you could do that also. You could put a little ice pack or a Ziploc baggie with some ice in there to store this. But when you go to disinfect with the bleach, you would have to obviously take it out. So that would work also. This could serve as your little cooler for a temporary fix, or for honestly most of the semester. You can just leave it out on the days that you're disinfecting. So let's talk about what you're going to do with this Serratia. So this is another bacteria. This is Serratia marcescens. And again, initially it kind of has a white appearance growing on the surface of the agar slant. So our agar slant is sitting like this, and growing on the surface is the bacteria, which is a white or pink color, or E. coli is white. So what you're going to do first, and I'm going to do the very short version because there's another video that you've got in the lab exercise, is you're going to make what are called stocks. This is the original culture, and stocks are basically what we keep to do the rest of the experiments. So we don't want to contaminate our stocks, because then all of our experiments the rest of the semester would have contaminated bacteria. So that would be bad. So what are we going to do next? And again, the long version of this is going to be in a different video. This is just kind of the brief, what's in the box, what am I doing first? So you would take your test tube rack, you would have all of your PPE on, because I'm not going to actually do it. So I'd have my gloves, I'd have my lab mat down, I'd have my safety glasses on, I'd have all my materials. Before you light the flame, have all of your supplies. So you're going to need 2 nutrient agar slants, so 2 of those. You're going to need 2 nutrient agar broths, so I have 2 of those. And then you're going to label them. So you have your little set of labels, and mine are yellow, yours could be a different color. And in the lab exercise, it tells you exactly what to label them. You're going to label it Serratia A and B, A and B. One is for the nutrient agar, and again, this is in the lab exercise. I know I'm going fast. And the other are for the nutrient broth. So basically what you're doing is you're going to make 4 more of what we currently have. So we would take our loop, we would obviously flame it with our little alcohol flame, let it cool. We would go in and get just a little bit of bacteria, just a little bit from the top, okay, after I've flamed everything. And I'm going to put it on the surface, kind of a zigzag pattern, just on the surface. We're not digging it on the agar, just on the surface of this nutrient agar slant. We do the exact same thing on this nutrient agar slant. So we have Serratia A and B. And what I mean by A and B is we're going to use some at the beginning of the semester. That would be Serratia A's cultures. And we're going to use them at the end of the semester, and those are Serratia B's cultures. It's the exact same bacteria, exact same thing. But we're just going to divide it into some we're using now and some we're using later. And it's also important to put the date, so that way we know when we did this. And you do the exact same thing with the broths, so A and B. So when we're all done, we're basically growing Serratia in two slants. We're growing more in two slants, and we're growing more into broths. So how will we know when it's grown? And it takes about 48 to 72 hours. So this will become nice and cloudy, or we call that turbid. Let's see if I've got one. Got kind of some stuff off to the side here. I may not actually have any. I don't think I do. Let's see, one more tube. Here's one. It's not very cloudy. Well, they'll be cloudy. It's okay, they'll be cloudy. And then, so this broth will become cloudy, which means yes, it grew. And how will you know if it grew on the slant? Again, on the surface of the slant, these will look like the original test tube that I gave you. So you'll have 4 more of what you already had. It's crazy important to make sure you use ASAP technique. So we're flaming our loop, we're flaming the tops of the test tubes before and after. We're making sure our environment is very sterile, because if you contaminate one tube, then likely you're going to contaminate all 4 tubes. And then for the rest of the semester, unfortunately, they're contaminated. So really watch that video that is listed in the lab exercise, so that way you know exactly what you're doing before you get going. And if you're not sure about what you're doing, contact your instructor and they'll be happy to kind of point you in the right direction. So the very first thing we're doing with the kits is making more stocks. So stocks are going to be 2 broths, 2 slants of just Serratia. We are not using E. coli initially. So again, store your little E. coli in your little pencil box on some ice, or store it somewhere else, refrigerator, etc. Again, if you're not wanting the fridge, cooler, small lunchbox. So now that we're all done, we're going to put everything back so the Serratia can go back in its little bubble wrap pouch. And once these are grown, so they're all grown, so let's pretend it's a cooking show. It's been a couple of days and there's stuff growing on them. So you can take all of these and put them together so that all the bacteria stay together in your little Ziploc pouches. And just be careful not to drop them. They're obviously glass. We don't want to break them. And then we're going to use these for other experiments. And you're going to want to make sure they're all lined up, they're all fit, all lined up together. There they are. Okay, your little Ziploc pouch, not Ziploc, but your bubble wrap pouch. And you can close it or seal it. And again, you can put that in this also, or in your cooler or in your fridge. So again, whatever you feel comfortable, but you're going to make sure you don't drop them, spill them, break them, nobody eats them, drinks them, etc. So put them in a secure location. All right, so that's what we did first, is we've unboxed our lab kit. We went through each of the items and kind of what we're doing with the initial experiment, which is to make more stocks. And then let's talk a little briefly about what else is in your kit. So you have a stack of 10 nutrient agar plates. So nutrient agar is basically the same exact agar that's in those slants, exact same thing. Agar is made out of algae, and it's kind of like Jello. So this comes as the powder. You add water, you bring it to a boil, and then when it cools, it solidifies just like Jello. So you have a package of 10 plates, and this is probably the most important part that I'm going to go through in this kit. So you're going to leave the plates, they're going to come in this package with a little twist tie at the top. You're going to leave them sealed until it's ready to be used. So when you get to the box, unfortunately because of the size of the box, it's going to probably have the plates on their side. That's not the best way that we want plates. So we always are going to store plates right side up, so the label's right side up. And what that's going to do automatically is make the plate, I'll show you this one, make the plate be upside down. And why is that significant? Well, it's very humid, and so we want the plate to be upside down so that any condensation we get forms on the lid. I'm going to be non-aseptic for a minute. Some of you can see there's lots of condensation on that lid, and we want the condensation on the lid and not on the plate. Otherwise, it's going to ruin the stuff growing on the plate. So we're always going to have plates upside down. So just to review, when you get your kit, your plates are going to be on their side to fit into the kit. As soon as you get home, you're going to want to take the plates out and put them upright. And that's going to ensure that the condensation only forms in the lid. If you get home, and I would actually not unseal this, don't unseal it, but if you get home and you do notice that there's mold growing on the plate, which there shouldn't be, we're going to try to make sure we give you non-contaminated plates. But if you do happen to notice mold, then you can open the package, take the plate out that doesn't have the, or that has the mold, and you can throw it away, basically. So the plates should not have mold. They should be all good to go. But if you have a plate that has something growing initially before you've done an experiment, then you can discard that plate. So let's assume your plates come and they look to be all good, like this set looks to be all good. We're going to take it out of the box, put it upside or right side up, and we've got a little twist tie. I have that, so it's going to come twist tied. So I would store these in 1 of 2 places. Again, if you feel comfortable, you can store them in your refrigerator. That's totally up to you. There's nothing growing on them. This is the same as having Jell-O in your fridge, so it's not going to hurt anything. Again, make sure no one in your family member tries to, bother it. If you don't want it in your fridge, again, there's nothing growing. It's like having Jell-O in your fridge. Then you could also use your little small cooler or a lunchbox. And if that's not available, which is fine, you could leave them at room temperature in your lab kit. That's not the best scenario, but it's fine. The more room temperature, the more likely bacteria or molds are going to grow. But again, if you don't have any of those things, that's totally fine. So what are we going to do with the plates? Well, the first real experiment we're going to do is we're actually going to do what's called a stray plate. So when you start to do those experiments, which again, there's videos, we're going to turn them right side up. And anytime that we are done with our plate, so we've just done our experiment, you're going to want to take 2 little pieces of tape. So you'll need, I don't care what kind of tape, Scotch tape, masking tape, I don't really care, just a little bit of tape, just need a little bit. And you're going to tape your plates closed. Okay, tape your plates closed. So that way, when we invert them to incubate, so incubate means time and temperature, let them grow, we always incubate them again upside down. So your plates are almost always going to be upside down, again, so that condensation stays in the lid. So just tape them closed with that little bit of tape, so that way no contaminants can get in. If you're concerned, so we're not going to jostle these around or throw them around, but if we're concerned about our entire sleeve of plate having issues, then you could take them out potentially and tape each one individually before you start your experiment. Again, I don't really recommend, I recommend not touching them much, meaning take them out of your kit, preferably stick them in the fridge, if not somewhere cooler, leave them packed just like this upside down. When I say upside down, this label is going to be right side up. So the plate, the auger will be, if you can tell, the auger will be at the top. The lid will be at the bottom. So put them in and then just leave them until it's ready to use them. You're provided with a total of 10 plates. You actually only need 7. So if something goes wrong with a couple, it's not the end of the world. You've got a few extras on purpose. All right, so that is the video on what is in your box, how to store the things in your box, a few little tidbits about what we're going to do at the beginning with our lab kit. And again, each video in the lab exercises will go through exactly the products that you need and how to use them, where to find them, etc. So I hope that was helpful. Good luck.